Alright, so in this video we go over section 5.5 factoring trinomials. So in this section we are going to factor trinomials of the form x squared plus b squared plus c and full factor polynomials of the form ax squared plus bx plus c. What's the difference between these two polynomials? Well, if you compare the leading term of both trinomials, for the first one the leading coefficient is 1, and for the second case the leading coefficient is a. In this case it's a number a different than 1, like a 2, a 3 or 4, etc. So let's start with the easiest case, factoring trinomials of the form x squared plus bx plus c. And I would like to call this I like calling this the double bubble method. That's how we call it. Why do we do that? Well, because we are going to factor trinomial. We're going to turn it into essentially a double bubble. You'll see. Okay. So number one, when the two things we need to keep in mind when factoring a polynomial like this is to make sure that the polynomial is written in descending order of powers. If it is not given like that, well, then you may need to rewrite the polynomial. Then what are we going to do? We are going to find two numbers whose product is the constant term and whose sum is b. Okay, so well, maybe a lot of letters, a lot of words. Let's see this in action. So let's factor x squared plus 10x plus 16. So double bubble. Both bubbles are going to have the x, and then we're going to look for two numbers whose product is 16 and add up to 10. Factors of 16 that add up to 10, these are going to be 2 and 8. Because 2 times 8, that's a 16, and 2 plus 8 equals 10. Final answer, as easy as that. Well, do you want to verify your result? Of course. FOIL, x times x, that's x squared. X times 8, 8x, 2 times x, 2x, 2 times 8, 16. Combine these two, x squared plus 10x plus 16. Same answer. Alright, let's do another example. Double bubble. Factors of 6 that add up to 1. So in this case, 2 and 3, because 2 times 3 equals 6 and 2 plus 3 equals 5. We're done with this one. Alright. Now, what if you did it in a wrong way? So what if you, because 6 is 2 times 3, right? But 6 is also 1 times 6. Alright, that's another way. If you did it that way, x double bubble plus 1 and plus 6. Let's say you did it this way. So indeed, this is correct. 1 times 6 is 6, but 1 plus 6 is not 5. So that's why we cannot factor it this way. But rather we go with the choice 2 and 3, because 2 times 3 is 6, and also 2 plus 3 equals 5. Let's do, in this case, one with negative numbers. That's where it's going to get more interesting. So let's see what we get. So double bubble XX. So factors of 35 that add up to 12. Well, 35 is going to give us 7 and 5 as factors, but in this case, notice that the product 7 and 5 has to be a positive number. But in this case, yes, the product of two positives is a positive, but in this case we want these two numbers to add up to a negative number. So in this case we have to make them both negative, because negative times a negative, 7 times 5 is positive 35, but in this case negative 7 plus negative 5, it's negative 12. Final answer. Same thing over here. Double bubble, factors of 24 that add up to 11. I can think of 8 and 3. 8 and both negative. Notice there's a few possibilities for the number 24. You know, for example, 24, let me double bubble it. The number 24 is the same as 2 times 12, right? Negative and negative. Let's suppose that. So negative 2 times negative 12 indeed is 24. However, negative 2 minus 12 is negative 14, not 11. So in this case, I cannot go with that choice. We also have the following option. 6 and 4. Negative 6 times negative 4 is indeed 24. But negative 6 minus 4, it's not negative 11. In fact, it's negative 10. So we cannot go with that choice. All right. So we have different ways to factor, but only one is the one that works. Now, let's look at letter E. For letter E, number 1, notice, as opposed to examples A through D, we have a third degree polynomial. But were we not supposed to factor polynomials of second degree? Well, in this case, we need to do something first before actually doing that factoring. We need to do the GCF. So we need to factor out the GCF, which in this case, well, 5, 30, and 35. 5 is part of the GCF, and then we factor out the lowest power of each term. So in this case, x. So in this case, that's going to be, we're going to be left with x squared minus 6x minus 7, because 5x times x squared equals 5x cubed, and 5x times negative 6x equals negative 30x squared, and finally 5x times negative 7 equals negative 35x. So now we're going to do double bubble on the remaining trinomial that is inside of the parentheses. However, don't forget to carry this 5x and then double bubble. Now we're going to look for factors of 7 that add up to 1. That means that add up to negative 6. So 7 and 1, those are the only factors of 7. However, I need a combination of signs in which the sum turns into a negative number. In order to get that, it is the largest number that has to have the negative. So negative 7 times 1 equals negative 7, and negative 7 plus 1 equals negative 6. Okay. Let's do another one here. Well, so in this case, 2n squared minus 38 plus 80. Well, I was under the impression that we were factoring polynomials with leading coefficient of 1. So leading coefficient 1, leading coefficient 1, leading coefficient 1, etc. But in this case, we can factor out the 2. So 2 times n squared minus 19 n plus 40. Now let's see if we can factor this into a product. That is, let's see if we can double bubble it. Can we find factors of 40 that add up to negative 19? Well, let's see. 40 is the same as 4 times 10. So if I had 4 times 10, that's a 40, but 4 plus 10 is not negative 19. Then we have the option of 8 times 5. So 8 and 5. So okay. So 4 and 10. That didn't work. What about 8 and 5? 8 times 5 equals 40, but 8 plus 5 is not negative 19. So I cannot use that one. What about 2 times 20? So 2 times 20 is indeed 40, but 2 plus 20 is not negative 19. So in this case, it looks like we exhausted all possibilities. So in this case, we cannot go any further by double bubbling it. All we can do is a simple GCF like in the previous section. Alright, let's move on to the next example, to the next topic, which is factoring trinomials of the form ax plus bx, ax squared plus bx plus c. And in this case, a is not a GCF as opposed to the previous example. So we're gonna call this we're gonna use a method called the diamond method. So there's many ways to factor polynomials of this form. There's the guess and check. You might have learned that in high school, the guess and check method. If that works for you, you're fine to you're good to use that method. Then there is the diamond method, which that's the one I prefer using, and there's other some sort of sorry about that, some sort of unofficial methods to factor the trinomial. Number one, it's called the slip and slide method, and the pizza method. So slip and slide and the pizza method. Those I don't cover when I teach this class. I typically cover this during office hours. So if you're curious to see how these methods go, feel free to reach me out during office hours, and I will be more than glad to show you how these two methods work. So in this case, we're going to use the diamond method to cover this topic. So for example, look at this polynomial. If we try to factor out the GCF, well, for the numbers, there is no GCF. So in this case, what are we going to do? We are going to draw a diamond, literally like a diamond here, like an X. Sometimes they call it the X method or the diamond method. And what are we going to do? We are going to multiply the leading coefficient times the constant term, that is 2 times 15, and I'm going to put that over here at the top, that is a 30, and the middle coefficient, it's going to be, which is 11, I'm going to put it below. Alright, so I'm going to find, just like the double bubble method, I'm going to find factors of 30 that add up to 11, and in this case, if I try to think of two numbers that add up to that two numbers whose product is 30 and add up to 11, one of them is 5 and the other one is 6. Okay, but what are we going to do with those two numbers? In this case, we're not going to do double bubble with this number, so we are going to break up the middle term into 5x and 6x. So 5x plus 6x equals 11. So I'm going to rewrite this entire polynomial to x squared plus 5x plus 6x plus 15. And then notice that we have 1, 2, 3, 4 terms. For that, we're going to use a method that we already covered in the previous section. Remember factor by grouping? Alright, so we're going to do factor by grouping. We're going to find the GCF of the first group. The GCF is only x times 2x plus 5. And in this case, the GCF between 6x and 15, they only have in common the number 3. So 3 times 2x plus 5, because 3 times 2x equals 6x and 3 times 5 equals 15. And if you recall how we did factor by grouping, notice we are going to find an overall GCF, namely 2x plus 5 times x plus 3. Final answer. Let's look at another example. So let's use the diamond method for this polynomial. And so to do that, we're going to multiply the leading coefficient times the constant terms. And in this case, signs matter. 3 times the negative 4, that's a negative 12. And then we bring down the middle coefficient, which is a negative 1. So we're going to look for factors of negative 12 that add up to 1. I can think of 3 and 4 as potential numbers because 3 times 4 equals 12. But I need to play with the signs in this case in a way that I get a negative product and a negative sum. So in this case, I need the largest to be the negative so that the product is, so the addition of the numbers is a negative number. Again, what do we do with these two numbers? We do not double bubble. So that turns into 3x, and that turns into negative 4x. So we do the following. 3x squared minus, oh actually plus 3x minus 4x and then minus 4. All right. So what are we going to do next? We are going to factor by grouping. Factor by grouping. Notice the GCF of the first group is 3x. So 3x times x and 3x times 1 equals back to 3x. And then negative 4x minus 4, they have in common the negative 4. And then we multiply this by x plus 1 because negative 4 times x equals negative 4x and negative 4 times 1 equals negative 4. All right. So again, what do we have in here? An overall GCF. So x plus 1 is the overall GCF, and that's times 3x minus 4. Final answer. All right, final answer here. So let's see. Let's do one last example, one more example. So let's do the diamond method on this example on letter C. So 4 times negative 6, that's going to give us a negative 24. And then the middle coefficient, which is the number 5, that's going to go down here. So what is this going to be? So I'm going to look for factors of negative 24 that add up to positive 5. All right. So in this case, I can think of the number 8 and the number 3. Of course, keep in mind that there's many different ways to factor the number 24. But we need to find a suitable one that gives us a 5. Also, I need a negative number somewhere. So 8 times negative 3 equals negative 24. But when I add them together, I get a positive number. So 8 minus 3, that's positive 5. 8 times negative 12 equals negative 24. So 8x and negative 3x. So what we do with these two numbers again is break down the middle term. So let's write this together. 4x squared plus 8x minus 3x minus 6. What can we do? Group. Because we have 4 terms, let's group this. And the GCF over here is going to be for x, 4 and the lowest power of x, which is 1. And when we factor out the 4x, we are left with x plus 2. And then the GCF for the second group is only the number 3. But notice they both have the negative sign in common as well. So negative 3 times x plus 2. Because negative 3 times x equals negative 3x, and negative 3 times 2 equals negative 6. So we have a few more over here. Something more to do, which is factor out the GCF x plus 2 times 4x minus 3. Final answer. Alright. Oh, we have more examples. I thought we were done only with this page. Okay, so let's look at something like letter D. So 12x cubed y minus 22x squared y plus 8x y. Notice the coefficients, they are all even numbers. Alright, they're all even numbers. And they also have the y as a GCF. So we're going to combine a few things in this one. I'm going to factor out the GCF first, in this case, which is 2xy. Alright, 2xy is going to be that GCF. And I'm going to be left with 6x squared minus 11x plus 4. And we're going to use the diamond method on the trinomial that we have inside of the parentheses. So 6 times 4, which is 24, and negative 11. And we already did the factoring of 24, that gives us 11 when we combine. So we use the numbers negative 3, right? Negative 3, well, actually in green, negative 3, and negative 8. Because negative times a negative is positive, 3 times 8, 24, and negative 3 minus 8 equals negative 11. So break down this negative 3x, and break that up as negative 8x. Alright, so what are we going to do? So this is going to be 2xy times 6x squared minus 3x minus 8x plus 4. And we're going to do factor by grouping inside of these parentheses. Alright, and then the need of having parentheses, inside parentheses, I'm going to turn these outermost parentheses into brackets. So 2xy times, so the GCF of this first group will be 3x times 2x minus 1, because 3x times 2x equals 6x squared, and 3x times negative 1 equals negative 3x. And over here, notice I have the arrangement as we did before. I have positive, negative, negative, positive. I need to have the same order of signs. So we need to factor the negative as well. And what do they have in common? The 4. 2x minus 1, because negative 4 times 2x equals negative 8x, and negative 4 times negative 1 equals positive 4. And then the overall GCF, 2x minus 1, 2x minus 1. I'm going to factor this 2x minus 1 times 3x minus 4. And I'm not going to write these brackets anymore because I already have this factored out. I'm just going to carry this 2xy. final answer. Let's do another example. Let's do many more examples. Okay, so I'm gonna do one more. So let's see. Let's multiply the leading coefficient with the constant term. So I'm going to multiply 6 times 6, which is 36. And then 13, I'm going to bring it down to the diamond. And I'm going to look for factors of 36 that add up to 13. So let's look at different possibilities for 36. So 36 is, well, 36 times 1, but 36 plus minus 1, well, it's not going to add up to 13. 6 times 6, well, 6 times 6 is 36, but 6 plus 6 is not 13. So we need to find another way. So what about 12 times 3? Well, that's 36, but that doesn't add up to 13. 12 plus 3, that's 15. How about 9 and 4? 9 times 4 equals 36. And so 9 times 4 equals 36, and also 9 plus 4 equals 13. So that's going to work. So break up the middle term into 9x and 4x. Alright, so that's going to be 6x squared plus 9x plus 4x and plus 6. We have 4 terms. Let's do grouping. Okay, so for the GCF between 6 and 9, what do they have in common? The number 3 and x. Okay, it's because in this case 3x times what equals 6x squared? That's 2x plus 3. 3x times 3 equals 9. Plus, factoring out between 4x and 6, the GCF, the only thing they have in common is, in this case, the number 2. So 2 times 2x plus 3 as well. Again, notice how we are supposed to obtain this same quantity right here. All right. So 3x plus 2, 2x plus 3. All right, final answer. Okay, final answer. All right. So in this case, I'm going to leave these two for you. Letter F, because this says F of fun. You're going to have fun with this one. And this is good practice for you. Okay, so when you submit your notes, on top of submitting all these examples, you are to work on these two. Okay, so I'm going to call it a day for this video. For this section, I'll see you on the next video.